Right, hi there. So this is just a quick recording of what I did in the lecture. So I went through it quite quickly. So this video is more just to show you which buttons to press really, and the nodes and the settings, because I know it's not easy to remember those things in a lecture. So what did we do? We created a torus. So hit there, hit enter. There's my torus object. Now I'll dive inside that. And if I press P, I can pop up the parameters. Now I think I doubled the rows and columns, just have a few more polys, and then I threw down a subdivide node. So I'm just hitting tab here. Tab, much like nuke, hit tab to bring up a list of the available nodes, then just start typing the name if you know it. So the subdivide, and again in the lecture I think I kept it at 1 and then it increased later on. So what we did, let's move that over a bit. First thing I did was just get rid of the geometry. Now I'll branch off sideways so I can bring the geometry back later on. And by changing this pattern to, at the moment it's not everything, so I'll just say delete everything except keep the points. And let's just close a few of these. So then we have the only data in the system now is a bunch of points, no vertices, no polys, nothing else, just points. And then I wanted to add some new attributes, so attribute create, and I created a float called initialize, and then if I click the plus here I can create another attribute. I'll create this one called accumulation, and now we've got these two new values. Default to 0 because that's what the default is. And if you remember in the lecture I showed you the alternative way, which was using a wrangle node, a attribute wrangle. Sorry, no, it's point wrangle. And for this let's move it over a bit. Same thing, I can just create the attributes but using a wrangle node. So f at init equals 0 and f at accumulation equals 0. Now the f stands for floating point number, so it means I'm creating a local attribute that is a float called init, and the at sign is just a sort of keyword for creating a local variable, rather than creating an attribute variable rather than a local variable. And if I click on that you can see we've created the two, which is identical to this one. So I think I'll stick with the point wrangle this time. We'll delete that one. Doesn't really matter which one we use. Although now I've lost everything. Where are we? There we go. So I've got my data back. And then what we did was isolated some parts of this using a sphere. And a group node. So I want to group all the points. So by default they're all selected, but I want to group by bounding object, which I should really plug in, otherwise I'll get an error. At the moment the sphere is bigger than the torus, so I'm selecting everything, so I'll just decrease that a bit and then move it to the, whoops, where am I moving it? To the right. There we go. So I've just got a couple of points there selected, and I'll call them group init. So that's my initialization group. And at this point I will copy this wrangle, Control C, Control V, and I'll just remove that, remove the F. Because this variable already exists, I don't need to tell it it's a float, but I do need to tell it it's now 1 for the members in group init. So for these, 5 points is it? They now have the initialized value set as 1. So we should see in here, we get, if I click on this, you can see we've got 5 points with a value of 1. So that's like the initial sort of seeding of the sim done. I say sim, it's, yeah, I suppose it's a sim. It's a SOP solver sim. Then what did we do? We said, yeah, put down a solver. So this is the thing that's going to do all the work for us. Dive inside, and it's these two nodes I want to deal with. The input 1, which is what's going into the first input there, the points themselves, and the previous frame, the previous values. Now I used a point VOP, so this lets me manipulate points. Plug those in. Make sure you turn this on. It's very common once you're inside a solver or a VOP and stuff, just to forget to turn it on, and then things don't work and you get confused. So dive inside this, and we end up with this sort of layout. Let's kind of move that out of the way. Now what I wanted to do here was to, for every point on this surface, I need to extract a point cloud of local points around it, find out what their values are, and then start spreading this accumulation value around. So I said point cloud open. There it is. So this opens a point cloud based upon the search radius, the point I'm selecting, and the number of points I want to look at. So I'll plug my P into P and output, was output 1 into, oh no, it's output 2 I think. Hang on, go back. Sorry, it's this one. Yes, output 2 into file. I'll just press P to close that. So that extracts my point cloud. I do need to, actually no, I think that's alright. Yep. I then need to use the PC filter just to filter out the attribute I'm interested in, which is the accumulation value. Now it is a float, not a vector. So that was, I should rename this. Yes, accumulation. So I'm just going to copy and paste those two, because I want to do that again, but this time taking the initialization value, so the init value. I then need to read in my current accumulation value, which isn't in this list, so you have to use a bind node just to find out what the value is. And it's the accumulation I'm interested in. So accumulates a float, that's alright. And then what I did was I just added all them together. Accumulation, value, value. And then what do we do? Yes, we had to clamp that just so it doesn't go above above 1. That's the default anyway, so 0 to 1, that should be alright. And then we did a bind export just to write out the new accumulation value that we've just calculated. So for this particular frame, it will do its calculations, write out the new accumulation value. The next frame, it will bring it in here, calculate a new one, and then write out a new one. So the accumulation will change every frame, gradually increasing. And we don't actually need this, so I can delete that. So I think that's all I need to do there. The other thing we wanted to do was visualize this. So again, it was an attribute wrangle I think I used. And that was at cd is equal to set 100. So I'm just setting the color to red. You can see there it's turned them all red. And then I said at cd.r Right, sorry, my phone went then, so I've lost track of what I was saying. So yes, so the CDR could be equal to the accumulation value, which hopefully when you click away will just colour in the initial ones. Now this could be CDR, it could be CDX, it's up to you. I think R makes more sense for colours. Just a different way of writing it down. It's because it's fundamentally it's a vector format. Now if I click play, it doesn't work. It does spread a little bit. I think you can see there there's a little change. But I've forgotten to do something. Somewhere in here probably. Let's have a look down here. I think it might be my PC open, maybe. Float channel, it looks alright. So something might just be a typo I've made somewhere. Wrangle. Let's try and play that again. Nope, it's not spreading those values out. I suspect, yes, it could just be the values that I've selected in the PC open. So this search radius might be too small for this geometry. If I just increase that a little bit. Then come out of it. Nope, still not going. Let me think. I think what it is my let's go back into the solver. I think I've just connected this up incorrectly. I think it should be op input 1 into the 2 file channels. 1 to file, yeah, that looks right. I was reading in the current values rather than the previous frames values. There we go. So essentially it was just it wasn't doing the simulation, it was just doing the previous frame. So that's the same. If I click this little clock, it will play in real time. And at this point I think I went to subdivide and just increased it just to get a bit more interest in that. Also it slows down the spreading because it's got more points to deal with, so it spreads more slowly. So that takes about 200 frames, I think. It's almost nearly there. Yeah, around 200. That seems like a nice time for the effect. Then the other thing we did was we played with the sort of the pattern that's formed. Because this is very regular, I threw in a point VOP just to mess around with the geometry a bit. So at this point I dove in, again just hide that. I took a noise of some sort, so I think I went for turbulent noise. Make sure it's 3D, and then we just added that onto the current point. So I take the point position, and that determines the type of noise for that particular area of 3D space, and then add that onto the output, and then plug that into the final position, and you end up with this messy torus. Now I could leave it like that, I think. Let's see what that looks like, the default. The danger here is that I've thrown some points too far away, so it looks too strange. So it doesn't, it can't actually reach them, but we'll soon find out if it can or not. Yeah, it looks like it's alright. It's getting in there. And then we got rid of this deformation just by using an attribute copy, I think it was. This is we need to copy to this from, where were we? Up here? I suppose that'll do. Not that one. Copy from there. So down here, if you press Alt, you can, much like Nuke, insert some handles to keep things a bit tidier. This is looking a bit messy at the moment. And the thing I want to copy, and see it's not worked at the moment, I need to copy the P value, not the colour. And then you get this sort of strange, uneven spreading across the surface, which looks more interesting. At that point, I started to delete stuff. Actually, I think at that point I copied everything back to the original mesh, didn't I? So I did an attribute transfer. Was it transfer? And I took the original geometry, which is this, transferred onto there. Now by default it copies the colour anyway, but I prefer just to type CD in there, just to be explicit in terms of what it should copy. There it goes. And now I can start deleting things. So I'll call this delete red. And we want to delete primitives, yeah, because it's now a poly object. Delete by expression, and the expression is going to be at cd.r is greater than, say, 0.2. So anything that's even slightly red is going to get deleted. And then I'm going to do just an attribute delete, just to visualize this a bit. And I want to delete the CD, just to get rid of that black and white colour, so black and red colour. It's useful for this, but it doesn't look that nice, so get rid of it. Now the other thing I could do was, actually let's make this a bit smaller, 0.1. I could copy this, paste there, and we'll call this delete non-red. And for this one I want to delete anything less than 0.1, or, which is the double pipe command for or cd r is greater than 0.999, say. So anything that is within the, anything that has sort of any sort of value other than 1 or less than 0.1 is going to get deleted, which gives us this sort of stripe moving along. Now, actually maybe I can make this a bit smaller. Let's make this 0.001. Get a few more polys in there, which means I probably want to make this one the same. Just because if I merge these together, I don't want any overlap in terms of polys. So if they're mutually exclusive, we get something that matches up. And then what did I do? I said I put down a pop network just to generate some particles from this one. Oops, rewind. And by default that just throws down some static particles, so we dove in there. Source is alright, but I want to increase my birth rate a bit. I think I went for 100,000. Life expectancy I set as something very small with a bit of variance. I think that's all I did. And then the other thing I did was put down a pop wind force. So I just plug that into there. Add a little bit there. See what that does. Maybe it needs a bit more than that. Ooh, that looks cool. It inherits the colour of the surface as well, so you end up getting this quite exciting coloration. And then I think what I did was I merged them together. So lob those in there, and you end up with this kind of effect. which looks quite nice. Obviously there's lots of variables there for you to play with, but if you want to make something disintegrate, I think this is quite a nice way of doing it. Looks kind of lava-y, doesn't it? Anyway, that's what we did in the lecture. I'll upload a video series for the melting bunny as soon as I get a chance to record it. I thought I'd just put this in for now, just so you can look at some of the values I'm playing with. It might give you some ideas of how you can control your own sims a little more. Right, I'll stop there. Cheers.